Alright, so we'll start from here. We have this question. It says solve for x in the equation. So the equation is 2 to the power 2x plus 1 minus 2x plus 1 plus 1 is equal to 2 to the power x. So this is a question on exponents. So what we must do here, remember the laws of indices. So when we have such a question, so on the first part, we can see that it's 2x plus 1 in the exponent. So this is the same. I can write this as x to the power 2x multiplying by 2. So since they have the same base, you can keep the base and add the powers. So which when we keep 2, we have 2x plus 1, which still gives us the same thing as we have done there. We can do the same with the other one, which we have 2x, then that multiplies with 2, then we have plus 1, then 2x there. Okay, then I can write this first part as 2x like that, then I can write the 2 outside. Here, when the power multiply, you just get 2x there in the exponent. Then this will be 2 minus 2x multiplied by 2 plus 1 is equal to 2 to the power x. So I can say this day, I can say let 2x equal to a. So let 2x equal to a. Then from there, when my 2x is equal to a, I can replace where there's 2x in my equation with a, and I have a squared. So it's multiplying with this 2 here. So that would be 2a squared. Then I have the next one, which is going to be a, like that. Then it's going to multiply with this 2, so I have minus 2a, then plus 1. Then the other side I have a. Okay, then I can bring everything to one side. So when the a goes the other side, it becomes that becomes negative a, and that will give us negative 3a plus 1 is equal to 0. Then I can solve for a here. So I must find a. So let's say my product there is 2. My sum is negative 3, which means my factors are going to be negative 1 and negative 2. When I add this, I get negative 3. When I multiply, I get 2. So I can replace that, and I'll have a squared minus 2a, like that, minus a plus 1 is equal to 0. Then I can group this, and I group the other part. Here, when I factor, I can factor out 2a, and I'll have a minus 1. The first one, I can factor out negative 1, and I'll have a minus 1, and that will be equal to 0. So from there, I can find the values. So that would be 2a minus 1, and I'll have a minus 1. So I factored it out, and I can equate this to 0. So I have 2a minus 1 equal to 0. Then I'll have a minus 1 is equal to 0. Then this will be 2a is equal to 1. So I can divide by 2 both sides, and I'll have a is equal to half. Then I have the other side, I have a minus 1 is equal to 0, and this will just be a is equal to 1. So these are the values of a. So after finding the values of a, what I do, I'll come back to this part. So the part where I said let my 2x equal to a. So this part here. So now what I do there, I'll just replace the values of a that I had. So 2x is going to be equal to, so I have half, and I have 2x equal to 1. So now, how do I get back to finding, how do I get the values of what of a? So in this second part, this one, it's easier to get the value of a because you know that the value that you replace here where x is has to give you 1. So if I keep the same base both sides and write 2 to the power 0 like that, here when I divide, since they have the same base, I'll just have x is equal to what? To 0. Any number raised to the power 0 will give me what? 1. So this satisfies that one. Then I have that other part where I have x equal to half. So for x equal to half, I'll just write it like this. So x is equal to that. Then I have, so here I can write the half as 2 to the power negative 1. So when I write it in a positive form, I get half. When I write it like this to the raised to the negative 1, I can write it like this, like 2 raised to the negative 1. So they have the same base here. So when they divide, I just have x is equal to negative 1. So therefore, my values of x are x equal to 0 and x equal to negative 1. Are there any questions on that one? Okay, so let's move on to the next one. So the next one, we have here, it says find the real values of x which satisfy this equation here. So how do we do that? So this is logs. We must remember the rules involved with logs. So a recap is when you have log, let's say base b, and you have x, and you have log b and y like that. This can be written as log b and x and y multiply like that. If you have log base b x minus log by, this can be written as log the b, that will be x divided by y. Another one to remember is when you have log b x equal to z like that, this can be written as, so this can be written as x equal to, so that will be b raised to the power z like this. So these are some of the rules that you should remember as we go through this question. So anyways, okay, so now let's do this question here. So it's base is 3, then I have x plus 1 there, then equal to 1 plus 2 log 3x minus 1. So here I can move this part there to the left side and I have log base 3x plus 1 like that. That becomes minus 2 log base 3, that's x minus 1 is equal to 1. So another thing we forgot to mention is when you have, okay, so when you have, for example, you have 2, you have negative 2 in this case, log 3, then you have, let me just say x like this. So this here can be written or is the same as saying x to the negative 2 like that. Yeah. So you can drop this power and write it like that. So even here, we will do the same. We have log, that is 3x plus 1 like that. Then here, what will I get? I will say this will be plus log 3x minus 1 to the negative 2 is equal to 1. Then here there's plus, so this is the same as multiplying. So I write log 3, this is x plus 1, then it's multiplying by x minus 1 to the negative 2 is equal to 1. Then this is going to be, okay. So next one, I can write that as log, then I have x plus 1 like that. Then I can write that other part as 1 over x minus 1 to the power 2 is equal to 1. And this here is going to be the same as log 3 like that, x plus 1 over x minus 1 squared is equal to 1. So I can write this. So this base here is going to sit the other side and to be x plus 1 over x minus 1 squared is equal to, so that will be 3 raised to the power 1 there. So we get this. Then now I can further work out this and find my values that I'm looking for. Okay, so that is going to be, I'll have x plus 1. I can cross multiply, so I get 3x minus 1 squared. And this is x plus 1 is equal to, can expand that. This here, I'll get x squared minus 2x plus 1. Then that will be x plus 1 is equal to, I'll have 3 here, 3x squared minus, that gives me 6x plus 3. Then I can group these. Let's say I move everything to the right side, so that would be 0 equal to 3x squared. That would be minus 7x like this. Then that would be plus 2. So this is 3x squared minus 7x plus 2 is equal to 0. Then we can now solve this here. So solve that quadratic equation. So we'll have, so we can use any method. Let's complete a square. So we can factor out 3, and we have x squared minus 7 over 3, x, then plus 2 over 3 like that, equal to 0. Then this is going to be 3. You have, so we have x, we write x, minus half of this gives us 7 over 6 squared. Then you have minus, so when we square half of that, which is negative 7 over 6, we just get 49 over 36. Then that will be plus 2, 3 like that is equal to 0. So we can compute that. That will be 2 over 3 minus 49 over 36. Then we get negative, so there we get 3. It will be x minus 7 over 6 squared. You get negative 25 over 36 equal to 0. Then you erase this part. Okay, so then next you multiply the 3 throughout, and you get 3 there, x minus 7 over 6 squared. Then that will be minus 25 over 12 equal to 0. Then you have 3x minus 7 over 6 squared. This fraction goes the other side, becomes 25 over 12. Then you can divide by 3 both sides. So dividing by 3, okay, 3, and you just have x minus 7 over 6 squared is equal to negative 25 over 36. Okay, this will be positive. Sorry, this is going to be positive, not negative, positive. Then from there, you introduce the square root both sides, this side and the other side. So we plus minus, then you get x minus 7 over 6 is just equal to plus minus 5 over 6. And this is going to be x is equal to 7 over 6 plus minus, that will be 5 over 6. So when we when we add the two, 7 plus 6 gives us 12 over 6. When we subtract, 7 minus 5 gives us 2 over 6. So there we'll get 2, and the other one will get this here, get 1 over 3. So the values of x are 1 over 3 and x equal to 2. So that's what you get for this question. Okay, now let's move on to the next question. We have this here saying find the exact value of the following expressions. So we have arctan root over 3. So arctan root of 3. This is the same as saying tan inverse of root of 3. So when you are finding the tan inverse here, what you're just looking for is the angle. So remember, if we had tan, let's say theta equal to what? Something here can be, okay, let me say x like that. So say x over what? Y. So when you say theta is going to be equal to tan inverse of whatever you get, x over what? Over y. So now we see that this here that remains, that's the angle. So now they've given us this part, and they've indicated that it's what? It's arctan, which is just tan inverse. So we must find the angle. So to find the angle, we must find tan of what? Of that angle. So to get that, we have to use special verses in this case, because they're involving root 3, and as you can see, the next one is root 3 over 2. This is just a special triangle. So if you have your triangle like that, and this is a 60, 30, so 30 there, and we're saying that's 30 degrees, 60 degrees, and that's 90 degrees. Distance from, so the distance from this point to that point is 1, and from the midpoint there to the other point is also 1. So here it just gives us, in total, this total distance is going to be 2, but from just this midpoint to that point, it's 1. Then from this point to the next one there, this is 2. And then from this point up to there, this gives me root of 3. So now, if I check here, which angle will give me what? Will give me root of what? 3. Which angle will give me root of 3? So when I check here, tan 60. So tan is given by tau I. We're saying tan is given by tau, which is opposite over what? Adjacent. So my opposite in this case, opposite of 60 is going to be here, which is root of 3. And my adjacent is this same part here, which is parallel to the 90 degrees angle. So it's going to be like that, I mean perpendicular. So that is going to give you, here it's 1. So you have the opposite, which is root of 3, and there 1. And this just gives you root of 3. So tan 60 gives us what? Root of 3. So in here, they're just saying if you do tan inverse, so meaning 60 degrees like that is equal to then tan inverse over root of 3. So they've given us this here, arctan 3. So meaning the exact angle, which here we found using this triangle, that would just be equal to 60 degrees. Okay, let's do the next one. The next one, dealing with the arcsine, which is just a sine inverse. So sine inverse of negative root of 3 over 2. So how do we get that one? So to get that one, we check here, we have 30 and 60. So for 30, So we know that sine is opposite over hypotenuse. So if we're at 30 here degrees, the opposite of 30 is what is this side? And this side is just what? 1. So that is 1. So we're saying sine theta, or in this case sine 30. Sine 30 is just 1 over what? So that is 1 over the hypotenuse is 2 there. So sine 30 will give us half, which is not the one we're looking for. So now when we do, let's do cos. When we do cos 30 degrees, cos is